Okay, next example, we have x squared plus 1 divided by x squared minus 4. So first of all, let's talk about domain. And again, when you're dealing with a rational function, what you have to worry about with your domain is what values are going to make it undefined, which would be any of those values that would cause your denominator to equal 0, and that would include a positive 2 and a negative 2. If you substitute either one of those values in, you would get 0 on the bottom. So x cannot equal positive 2 or negative 2, okay? So that's going to play a part with what we're going to do here in just a little bit. Okay, first derivative. Now, because you're already accustomed to doing derivatives, and this is going to be quotient rule just like the last example, I'm just going to kind of cheat here and save us some time, and I'm just going to go ahead and tell you what these derivatives are. Now, what I would suggest you do, though, is you work it out in your notes and see if you get the same answer that I'm fixing to give you, okay? So your first derivative, you should get negative 10x divided by x squared minus 4 and that quantity squared. So like I said, work out your quotient rule and see if you get the same thing I get. That'll give you some, practice in doing that. I'm just doing this just to cut down on time with the videos. All right, second derivative. Again, you're going to have to use quotient rule. So using quotient rule on your first derivative, you'll end up with this. And again, it'll be very similar process to what you saw just a few minutes ago. Okay, so this is going to be your second derivative. Okay, now from your second derivative, we've got to find out what makes it equal 0 and what makes it undefined. Okay, so if I set my numerator equal to 0, okay, so again, if I divide my negative 10, this is still just 0, so we can just ignore that. I'm going to go ahead and add the 4, so negative 3x squared is equal to 4. So x squared would be equal to negative 4/3. There's really not any need for you to go any further with it, because your next step is going to involve you taking square root of a negative, which is going to be imaginary. So you can just go ahead and stop right there. You're not going to get anything from that. All right, with your denominator, x squared minus 4. And again, you really wouldn't have to do the third power, because if you take cube root, you're still going to have 0. So you get x squared is equal to 4. So x is equal to plus or minus 2. So on my sign graph, I'll have negative 2 and positive 2 that I'll put on my sign graph. Okay, my test values, I'm going to go with negative 3, 0, and positive 3. And remember, you're going to substitute these test values into your second derivative, okay? So if you were to substitute negative 3 into the second derivative, you're going to get something that's positive. If you substitute 0 in, you're going to get a negative. And then if you substitute 3 in, you're going to get a positive. So that means that we're dealing here with concave up, concave down, concave up. Okay, so let's write those intervals. So concave up would be negative infinity to negative 2, and then from 2 to infinity. And concave down would be negative 2 to positive 2. Okay, now points of inflection. That's where this problem's a little bit different from the previous examples. Because when you look at it, you would say, okay, well, my concavity changes here at negative 2, so negative 2 would have to be a point of inflection. But if you remember, negative 2 is one of these values that's not in the domain. So if it's not in the domain of this original function, there's not a point there. Okay, and we're going to look at this on the calculator just a second for you to see what's actually going on at -2. But if it's not in the domain, it is not on your graph, so therefore it cannot be a point of inflection, because remember, this is an actual point. Okay, same thing is going to be wrong with +2. +2 is not in your domain, therefore there's no way that it can be a point of inflection. So we'll just say none. And if you might want to make yourself a note that just says +2, -2, not in domain, just in case you might forget why in the world we didn't include those. It's because it was not in the domain to begin with. Okay, let's look at this one on the calculator. So again, I've gone ahead and put it in my y equals. Now this is just the standard window, like if you do zoom 6. So this is -10 to +10. Same thing on the y, -10 to +10. So we've left 2 and -2 out, but if you will notice what's going on is at -2 and also at +2 is where you actually have vertical asymptotes. Okay, so your concavity can change on either side of a vertical asymptote, but it's changing at an asymptote and not at a point. Therefore, that's why there's not a point of inflection. So remember, this was the section that was concave up, and then the middle section was concave down, and then this section was also concave up. Okay, but again, you don't have points of inflection because they're not in the domain. They're actually vertical asymptotes.